So today we are here to tell you about a project which is an obstacle detector for blind people. So basically our project is based on Arduino and required sensors that we are using in this project. So first of all I'll tell you about Arduino. What is Arduino? Here you can zoom in and see that this is an Arduino board which is an Arduino Uno board. So here we have the COM port from which we connect it to a power bank or a computer. Now these are the analog pins and these are the digital pins. So in an Arduino we have analog pins from A0 to A5 which are 6 pins. Now here we have the V-in ground pins 5 volt, 3.3 volt pins. Here's the reset button. Here is the IOREF pin, and again here we have the digital pins. So in digital pins again you can see we have ground here, AREF here, and then pin number 13 to pin number 2, and then this is the TX and this is the RX. Here are where we make the connections for our digital circuits, and here is where we make the connections for analog circuits. Now I'll tell you about the sensors that we have used in this project. The first sensor or the only sensor we have used in our project is an ultrasonic sensor. Now let me tell you what an ultrasonic sensor is. Basically an ultrasonic sensor is like a tiny speaker plus a tiny microphone. Now here we have one transmitter. You can see a small T written over here. This is the transmitter. And this you can see there is an R written over here. That is, this is the receiver. Now what an ultrasonic sensor does is, it sends out a high frequency pulse from the transmitter which hits an object in front of it, and then the echo is reflected back into the receiver and the receiver accepts that pulse. Now what actually happens after that is how the ultrasonic sensor works or tells us about the distance. Now the speed of light is approximately 341 meters per second. Now what it does is, when the transmitter sends an echo or the pulse returns to the receiver. This is the distance d, for example, the first distance, and then when it comes back it becomes 2d. Now what we have to calculate is the total distance. So we know the time that the pulse has taken. The ultrasonic sensor actually calculates the time. So the time into speed divided by 2 is the distance. So that's how we get the distance between the object and the ultrasonic sensor, and that's how we are using it in this project. So what ultrasonic sensor will do in our project is, it will calculate the distance between the obstacle and the person, or where the ultrasonic sensor is actually fitted, and then it will tell us how far or how near we are to an obstacle. So that's how we come to know that we are in danger or not. Now, after calculating or sensing the distance that we are doing through the ultrasonic sensor, we need to know the distance. Not exactly the distance, the output. That is, are we too near to the obstacle or we are at a safe distance? So to know that, obviously blinds cannot see any physical signal that we are giving. So we are using a buzzer. That is, this is a piezo buzzer. We see this is a ground and this is the signal or the pin number that we will connect to the Arduino. So now this buzzer will be connected to our Arduino, and when the ultrasonic senses the distance, this will be buzzed if the distance is too near. That is, we will achieve it through coding. If the distance is less than 40 centimeter, then it is not a safe distance, so the buzzer will be alarmed. That's how it works. Now I tell you about the pin diagram of an Arduino. So here we see the pin diagram of an Arduino. We see the reset button, the pin RX, pin TX, and then we see all the analog pins over here. Then we see the digital pins over here. Everything we can see. Here are the analog pins. You can see analog 0, 1, 2, 3, 4, 5. This is the ground. This is not connected. That is the free slot. Then we have 5 volt, pin 1, pin 2, 11, 10 and 9. Here we have the digital pins. Again we have the ground, crystal pins, pin 5, 6, 7, 8, and above that we have 4, 3, 2, RxTx and reset. Now I'll explain to you the pin diagram of our project before we begin with the connections that we actually did during the project. So this is the Arduino pin diagram, as you can see, and this is the ultrasonic sensor. We saw the actual sensor, and this is the pin diagram. This is a schematic diagram. This is a 3-pin ultrasonic sensor. Actually we are using a 4-pin diagram, but to explain in a very precise manner we used a 3-pin diagram to show you. This is the buzzer again with 2 pins. Buzzers are available in 3 pins also, that we'll explain to you later after the project. About the connections also we'll tell you, but now because we are using this buzzer which has only 2 pins, 2 connections, we are telling you about this only. So here we see we have the ground, 5 volt and signal. The signal goes into the pin number that we are actually using on an Arduino board. So for example, this is the digital pins we see over here. This is the digital pins. For example, this is 7 we see, and if we put our ultrasonic, this is the buzzer for example, this will go into the signal. Similarly, we have this ultrasonic sensor. Here there are 2 pins, trigger and echo, which I'll explain you how to connect. But here, since we have only one signal pin, you will connect it directly to any one of the digital pins available on the Arduino board. Now again, we have the 5 volt here, that is the voltage we have to connect it to the Arduino. So here we see on this side of our Arduino, here we have the 5 volt pin slot. So here it will go, we will connect it through our jumper wires, and then we have the last ground pin that will be connected to the ground slot. And now this is how we do the connections. This is a male wire. You can see both sides are male. So this we'll be using in our project. I'll tell you how. Now there's this female wire. Both sides are female. Now the problem with this, what we are doing here is we have to connect this with, that is a female with a male, so that we can make connections. Now the thing is that on an Arduino board you need to connect this male wire into any of the pin slots, and while we are using any sensor we need to connect the female side of this. And to make it more simpler, rather than connecting 2 wires, we also have an hybrid of what we call a female and a male, so that we can directly connect the female section of this wire to the sensor we have or the component we are using, and the male part directly to our Arduino board. So now let's move on to the connections. I have already connected the male and female wires in this way already, so that I get more of a space for connecting these components with the Arduino. So let's begin. On an ultrasonic sensor you can see that we have VCC, trigger, echo and ground. This is a 4-pin ultrasonic sensor. We have 3-pin also, but here for our project we are using a 4-pin ultrasonic sensor. So let's begin. I'll first of all make all the connections in the ultrasonic sensor. That is, I'll connect it to ground, 1 pin to the ground, 1 to the echo, 1 to the trigger, and then at last we have 1 for our VCC. Now we'll connect it to the Arduino. The blue one is the ground. So here I'll connect it to the ground. You can see this, the ground. Then the orange wire we've used here is echo pin. Now in the code we have, now according to the code you have to connect the pins. The same pins that you use in a code, that number only you have to use it on your board also. So in my code I've connected the echo to 9 and my trigger pin to 10. So here I've connected both my pins, and then I have the red one as VCC. Now VCC goes into the 5 volt slot here. So our ultrasonic sensor and our Arduino are connected together. It's done. Now let's move it aside and I'll tell you how to connect this buzzer. It's very easy to connect the buzzer. I'll put this into the ground. You can see I've put it in the ground, the black wire, which is the ground wire, and then I'll connect my signal wire to the 7th pin. That is again what I've used in my code. It goes into it, and we're done. This is our Arduino code. You can see here. You can get these kind of codes on the internet as well, but explaining the code in such a short period of time is quite difficult. So because of time constraint, we're not explaining the code and we're just moving on to how our project runs. So the distance that we have set is 40 centimeters, as I told you earlier in the video as well. So here we move on to the execution of our project. You can see that here we have the ultrasonic sensor. So since the camera is now too near to the ultrasonic sensor, the distance is already less than 40. So the buzzer is buzzing. You can hear the buzzer buzzing here. Now there is no obstacle near the ultrasonic sensor. My hand is very above, so you cannot hear the buzzer buzzing. As I take it near, you can see that the distance is less and the buzzer is also buzzing. You can hear the buzzer buzzing. So you can hear the buzzer buzzing. And that's how our project works with the help of an Arduino